forget everything you think you know about psychiatry and only listen to what I have to say about fatty acids. That is how Hanneke Assies started her lecture as a substitute teacher several years ago that I was attending as a medical student. And back then, I thought, who is this lady? And I was critical and a bit suspicious. And Dr. Assies felt my criticism, and she said, well, if you don't like what I have to say, you can leave the room. That moment I chose to stay, and that's why I'm standing here now. And Dr. Assies continued her lecture by showing that the brain consists of 60% fat. And back then I thought, okay, that may be so, but what's the relevance of all this fat? During my psychiatry class, I never heard about fat. If neuroscience was covered at all, it was mostly about monoamine neuron transmission. So the relevance of this fat, I didn't know back then. And Dr. Assies showed that this fat can be found if we zoomed in on the brain, on the neurons, and particularly the synaptic membrane. The synaptic membrane is made up of phospholipid bilayer, and this is where the fatty acids can be found. And on the right, you can see a membrane that consists mostly of saturated fatty acids. And they have a straight molecule structure and can be tightly packed, and this leads to a more rigid membrane. And on the left, you see a membrane that has more unsaturated fatty acids. Due to the double bonds in the molecule structure, they have a curvature, leading to more space between the molecules, leading to a more fluid membrane. And this membrane constitution can be compared to butter. Butter has relatively little unsaturated fatty acids and is solid, versus oil that contains more unsaturated fatty acids and is fluid at room temperature. And the fluidity of the neuronal membrane has important consequences for the functioning of membrane-bound proteins like neurotransmitter receptors. And in the brain, the most important fatty acids that are unsaturated and responsible for this membrane fluidity are the omega-3 fatty acids. And the omega-3 fatty acids also have another important characteristic. They are precursors of eicosanoids like prostaglandins that reduce inflammation, which can be relevant for psychiatric disorders, given that they are often associated with increased inflammation. But this role in membrane fluidity and inflammation is not the reason that we call omega-3 fatty acids essential fatty acids. That is because we can only obtain them from diet. So this may give ground to the well-known proverb, you are what you eat, given that also your brain consists of fat that you can only obtain by diet. And that may make you reconsider your dinner choice this evening, given that we eat less and less fatty fish, which is the main dietary source of these omega-3 fatty acids, since industrialization, thereby risking an omega-3 fatty acid deficiency. So with this information, Dr. Assies called my attention for the role of omega-3 fatty acids in the brain. But still, what's their relevance for psychiatric disorders, I thought? And this is a graph that for the first time drew attention for psychiatrists and neuroscientists for the role of omega-3 fatty acids in psychiatric disorders. On the x-axis, you see the amount of fish consumed in a nation. And on the y-axis, you see the annual prevalence of depression. And as you can see, there's a strikingly negative association. But as may some of you now have as well, as a student, I thought, well, what is this data? Why are these particular countries chosen? The depression prevalences did not match the numbers I've learned during psychiatry class, and the article was already more than 10 years old. So I tried, let's replicate this in a more recent set of data. And here you see the same graph, with on the x-axis the fish consumption, and y-axis the average depression score on the validated depression questionnaire for only European countries. And to my surprise, when I tried to replicate this, I found a similar negative relationship with less depression in countries that eat more fatty fish. And this continued to interest me for the role of omega-3 fatty acids in depression. And therefore I started to do follow-up research. And in this follow-up research, by us and others in cross-sectional research and also prospective cohort research, we again found this negative relationship with less depression in people that eat more fatty fish, and that also remained after correction for confounders. So these were interesting results for me, and I thought maybe this Dr. Assies isn't so strange after all. And I started to do, I started being a clinician as well. I started to wonder how we can translate these findings to the clinical perspective. And to that end, it is essential to know whether these observational relationships actually imply a causative relation. So the actual hypothesis, the one already stated by Hippocrates more than 2,000 years ago, could it be that food can be used as a medicine in the treatment of, for example, depression? Unfortunately, it's hard to study dietary interventions like fatty fish in a controlled fashion. It's hard to imagine eating fatty fish double blind. But luckily, we can isolate the omega-3 fatty acids from fatty fish and put them in a capsule and compare them to a matched placebo. We and others performed randomized controlled trials where we compared these interventions and which allowed us to perform a meta-analysis of the performed randomized controlled trials. And when planning this meta-analysis, I still was a bit critical. Okay, I learned, like you just now, about the role of omega-3 fatty acids in the brain and the relationship with psychiatric disorders like depression. But still, could a simple nutrient be effective in the treatment of depression? When pooling the available data from in total about 1,300 subjects, to my surprise, I found that the omega-3 fatty acids were more effective than placebo. And moreover, they showed a medium effect size that may even be clinically relevant. So I tried to put these findings in context by comparing them for effectivity data for traditional antidepressants. Here you see a recent meta-analysis published in The Lancet with effectivity data for all traditional antidepressants. And I put the omega-3 fatty acids on this list. And as you can see, the omega-3 fatty acids, the effect size that I found in my meta-analysis, was second on this list. But what was really important for me, that all the other antidepressants were designed to share a common mechanism of action, modulation of monoamine neurotransmitters, while the omega-3 fatty acids, they work in a totally different way. They modulate membrane fluidity and inflammation. So it's not only that they work, but they work in a totally different way. So these data were really fascinating to me. Dare I even say really cool. And I started to think how we could translate these clinical findings back to the neuroscientific perspective. So in depressed patients, we indeed found an association between omega-3 fatty acids and inflammation in the form of CRP, and also with the activity of the hypothalamic pituitary adrenal axis in the form of cortisol. And if we zoom out even further, we saw that the omega-3 fatty acids in depressed patients were associated with activity of brain regions like the amygdala. So together, these data suggest to me a neurometabolic network of associated alterations in fatty acids and other pathophysiological mechanisms that can be effectively targeted by omega-3 fatty acids from the diet and can be helpful to treat depression beyond monoamergic neuromodulation. So looking back, I made a personal journey during my research from being a skeptical student to an independent researcher, and I was able to personally verify the results I initially found hard to believe. And that's why I would like to conclude by saying, forget everything you think you know about psychiatry and only listen to what I have to say about fatty acids.